Hey folks, welcome back again to Advent of Code in F#, day 13 already, which makes me happy, but also a bit sad, because we are crossing the halfway point of the puzzles. 5 seconds to go for the puzzle, so let's just dive in and take a look at what Advent of Code has in store for us today. Transparent origami. You reach another volcanically active part of the cave. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. When you activate it, you are greeted with... Congratulations on your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual. Oh no. Apparently we're the first ones to use it. Elves never used this feature. To your surprise, you manage to find the manual, but as we go to open it, page 1 falls out. It's a large sheet of transparent paper. The paper is marked with random dots and includes instructions on how to fold it up, which is our puzzle input. Cool. Now I'm curious about transparent paper. Okay, they just mean those plastic sheets used for old school projectors. In my time, yeah, people still used plastic sheets and projected them on a wall while teaching, stuff like that. Apparently, yeah, okay, we've been there, so these are random dots. And we get like two fold along commands. Yeah, so we have random dots and instructions on how to fold it up. So first is a list of dots on the paper. 0 is top left. Yep. First value x increases to the right, so that is the column value or the horizontal value, and y is row value or the vertical value. That is, of course, makes sense. So the coordinate 30 is to the right of 00 and the coordinate. Yeah, okay. This is the printout of the example. What am I seeing here? What is that? 11-0, 11-2? So 2, 4, no. 12, no. What should this be? 0, 12, something like that? 0 to 13, okay. And the other one is 0, 2. 2, 13, sorry. I am not seeing it. Never mind. It'll be correct. So we have, after these points, we have a list of fold instructions. Each instruction indicates a line on the transparent paper and wants you to fold the paper up. Fold paper up. Or left. What does it mean to fold something left? The first fold instruction is fold along the y-axis, or y is 7 axis, which designates the line formed by all of the positions where y is 7, marked with a minus. So we need to fold up over this line. Okay, we need to fold the bottom half over to the top, and because it's a transparent sheet of paper, okay, I see where this is going. Points might overlap, but points will never disappear. Oh, sorry. Points will never appear on a fold line. Okay. And we will have a magic word after the folds. This is a cool puzzle again. I love it already. Notice, for example, the 2 dots in the bottom left corner before the transparent paper is folded. After the fold is complete, these dots appear in the top left corner. Yes, because the paper is transparent, the dot just below them remains visible. Just below them. What is it saying? This one? Probably. No. 0, 3. That's the first column, third row. 1, 2, 3. Oh, this one. Yeah, okay, so if you fold transparent paper over, you still see the paper below. And some dots can end up overlapping. Yes, we already know this. Folding along the x-axis gives us something like this. Okay, so we have both a y fold and an x fold. It's even the same example if I look at it. Yeah. Okay, makes sense. Paper is pretty big, so for now, focus on just completing the first fold. What? Just do one fold, okay. So we just need to handle the first fold instruction and count the number of dots that remain. It's slightly disconcerting. What does, how many folds and how many points will we have? Quite a bit. Let's grab our input. Which example do we want? Yeah, let's just take this entire example. Data structures. What does this look like? What will we be needing to do efficiently today? Folding. Folding, what does that mean? Taking part of our paper, flipping it along some axis, merging it with another. What does this sound like? The hard part for me, or the part that I feel less comfortable about is, or least comfortable about, is the flipping part. Actually, it's not that bad, right? If we flip a horizontal, or if we fold the horizontal line, we just take the bottom half of something. I'm trying to make a decision or whether or not to go for 2D arrays or lookup tables again. We have been using lookup tables quite intensively for all the days. Maybe it's time again to flex the 2D array muscle a bit. See how that works. Yeah, I'm gonna use 2D arrays today. So first things first, let's parse. If we use a 2D array, this is a sparse kind of thing. I was thinking about when do I make the decision between a lookup table or a map and a 2D array, because 2D arrays are really fast for accessing. They're like constant, or it's really fast to find elements at a given location. Maps as well, but it's a bit slower. But I think for me the biggest distinction is if it's a sparse matrix, like if not every point is super relevant and you have a lot of empty points, then it makes sense to go for a map-based approach, I think. And this is one of those sparse problems where you have a lot of empty spaces. Yeah. We need to know the dimensions. No, I don't think we really do need to know the dimensions. I'm gonna go with a map. Forget I said I would flex or exercise the array 2D muscle. Let's not. Let's go for a map because of sparse. So we need to parse this thing into a map. Why a map? It's just a set of locations, right? Yeah, I think maybe even a set. We have no values, we just have coordinates or locations. And folding will remove duplicates if we use a set, so we get that for free. It's also pretty quick to access and look up stuff. To find like everything we need to fold. Yeah, let's go with a set. So I'm gonna introduce a new type. How do you do set in a type signature? Generic argument? Yeah, generic argument of int tuples. Is row column going to bite me today? X was the column, right? Yeah, X is the column, Y is the row. I'm gonna wing with it. If it even ends up as one bug, we'll do something about that. But right now, we'll go with it. So where X is horizontal, Y is vertical. And if we fold, we need to fold or in a different direction. But okay, let's parse this thing. First thing we need to do is split. Do we? Yeah, let's take while. Let's divide this string up into two. Should we? Should we? Yeah, let's divide this string up into two different parts. One for the points, the other for the instructions. Let's see if we can do something with take while. Is this something? No? Maybe if I use correct module, yeah. Is this something that looks correct? I think so. So these are the points and these are the instructions. So skip while or skip the points, the number of points, and then probably one more. Yep. So can I do this? No. Can I do this? Good enough. So these are the two parts of the input. Points, we can just parse it to our xy's. Yep. That's point text map, and that's a single line. Let's do a parse point function. That makes more sense to me. So point from a line, which is a string. Let's help the compiler out here. So then we can split all comma. That should give us two numbers. So that is x and y. Where's my closing? There, it's my closing bracket. So this is x and y, and let's parse those into integers. Yeah, integers are enough. This should give us something. Is 6 then right? Correct, yes. 90 is also correct. Cool, looks good. Instructions. Yeah, let's parse that as well. I'm gonna make a new type, a record or a discriminated union again. So folding along the y-axis or folding along the x-axis. And now that I see this, why not do x first? There we go. So let's also write a parse instruction. Very similar. We can just forget about this part. So let's split on space. Where were we? Oh, right here. So let's split on space. And that gives us this substring. So let's pattern match on that. Oh, is pattern matching a good thing? Do we have like multi-digit folds? Yes, we do. So no, let's split again on equals. I was going to pattern match on this string, but then yeah, actually that would work. Nah, we've been splitting. Let's keep splitting. So we split on space, then we get the second part, then we split that thing again on equals, and these are the things we want. So that is a... I am having a real hard time finding my brackets today. What is this? The dimension, x or y, and the distance, or the how do we call that? A line. Yeah, let's call it line. And now let's pattern match on the dimension. So this can be x or y. In the next we have a fold x, and let's just parse the line. Sure. And for y we do the same. So this should parse nicely. Yeah, except for when we have malformed strings, but I don't think we will have any malformed strings today. Match cases were incomplete, actually. What? We do have a problem. That's interesting. Is it in the points? No, because we are not pattern matching over there. We are pattern matching over on instructions, and apparently we are doing something wrong here. Let's print out the unknown case. Those are all strings, right? Strings, yeah, let's keep that typed. So it is unknown, and the entire thing is line. I'm gonna enter some markers to more easily see what we're printing out. There we go. What is going wrong? Sorry? I'm not seeing anything in my printout. Why are you crashing? Is it crashing over here? Oh, are we still not skipping the... Well, what does instruction text look like? No, that looks correct, actually. Okay, let's start printing out. Interesting. I don't see my problem. So let me... make me see it. I'm confused. Why am I not seeing printouts? So this is all happily chugging along, but when we try to parse instructions... Oh, there we go. We're parsing fold along y equals 7. Yeah, that is the first instruction. Okay, let's grab this and play around with it. So I just assigned the variable line, or this string, to the variable line, and now I can just select random snippets of code that reference something called line. Oh, of course. There's more than one space in this instruction. This is not correct. I could do the hacky thing and just... It'll always be a fold along thing. Yeah. So I'm gonna squint my eyes and allow this. Fold y over 7, fold x over 5. That is correct. So yeah, that's parsing, or it is parsing if we put this in a set at least. I would like to work with sets today. One disadvantage, it orders, yes, it sorts every point because it uses some kind of tree structure in the back, but that's not too bad. Let's write a parse. And this is not the entire parse logic, there is a bit of parsing going on here. So let's take that as well. And let's return our points and our instructions. And input is good enough, yeah. So let's use input instead of the example so we can parse anything thrown our way. Cool. That took longer than I hoped, parsing today. Let's see what we get for the example. That should still work. If I can type at least. Yeah, that looks good. Let's see if we can parse the real thing. Yeah, that's a lot bigger. So we have our set of points, which will make deduplicating when folding a bit easier. I don't think we need anything more complex than this. And a list of, or an array of fold instructions, which we have to apply on this thing. So what will the remainder of the algorithm look like? We will just do something for every fold. So that is a reduce or a fold again, or a fold function. We are going to fold over folds. That sounds very meta. But before we start folding over folds, let's maybe see if we can handle just a single fold. Yeah. So let's grab this for our example so we can play around with it. So this is the paper and the instructions. Yeah, we have our paper and instructions, and the first fold that comes along is fold along y equals 7. Y are the rows, so we should fold along magical line number 7. What happens if we fold? If we fold over the y line, we grab everything on the paper that has a y coordinate larger than what we're folding over. And we change, but how do we change? Like the farthest point out, let's say it's a paper of 20 rows. If this is like number 20, that becomes number 0. And number 11 becomes number 9. Right? So we leave the x component of the coordinate untouched, but we flip or we inverse y coordinate. 20 becomes 0, 19 becomes 1. What is that? That is 20 minus... Will it always fold in half? Probably not. Let's take a look at our input again. Do these numbers appear to go down by halves? Yeah, I think they might actually go halfsies every time. Yeah, they go half. So we fold the paper in half every time. There's no funky stuff going on. So it's a really basic origami. But anyway, I am trying to figure out how I calculate the new coordinates if we flip horizontally, or if we flip over a horizontal line. I'm saying flip, but I mean fold, of course. So what is this point? 13, 0? 14, 0, sorry. That's why I was not finding it a while ago. So 0, 14, if we fold that over y equals 7, oh, this is confusing me. We fold over y equals 7, but we are going to... change the y coordinates still. Y are rows, right? It's confusing me today for some reason. Y's are... yeah, Y's are the rows. Okay. So 0, 14 should become 0, 0. And that is 14 minus 14. Is that how we do it? So 14 minus 13 becomes a 1. Yeah, actually that might be it. So we need to know the dimension, or the dimension is 2 times the fold line. That's maybe even easier, then we don't have to go reach into our paper to figure out its dimension or keep track of its dimension some way. Yeah, let's use the instruction we get and figure out the dimension from that. And then just do the maximum dimension minus the current dimension, which should maybe potentially be fold along the y-axis at least. So let's try that. Let's try folding along y equals 7. Should we make a smaller example? This is already a lot to it's a lot of mental gymnastics for me. Maybe we should make a smaller example. Nah, we're good. It will be a lot of typing and it will amount to not much. So, okay, let's do a fold. Fold a paper according to an instruction. I'm using explicit pattern matching here, not the function hacky thing, to make it really clear what we're doing. Fold y is the first thing we're going to do, so I'm just going to implement this case first. And this should return a new paper where we did something. So let's try that with our current paper and our first instruction. Sorry? Oh yeah, it's instructions. Okay, come on, give me something. Okay, it's giving me something. So what do we need to do? We need to figure out the dimension. I'm just gonna do it inline here and see how bad it gets before I extract the function or something. So I think we want to do this. I'm not sure. Paper, we have instructions. I'm gonna grab this and assign it to instruction. If you use it in a REPL, it's the last evaluated thing. So now we have everything and we can select code and do stuff. So, but that's not really useful, but okay. So length is 2, that's 14. Now grab everything in the paper. Grab everything in the paper that is larger than length. Yeah. I'm not gonna grab it. I'm gonna keep it where it is, but I'm gonna use a map function. Otherwise we will have to delete stuff out of the set and then insert new stuff. And why do that if you can just use a map function? It makes this function a bit more complicated, but because now we need to do, hey, are you an interesting case or not? But it allows us to only pass over this set once. Not that performance, or I don't think performance will be an issue today, because we only need to do what? 10 folds? Yeah, something like that. But anyway, let's do it this way. So when do we need to do something? If our y coordinate is larger than the length. Yeah. If y is larger than length, then we need to do something. Otherwise, we don't. This is already becoming a 3-4 line thing. Let's extract this. Yeah, let's extract this. I'm thinking about the order of arguments here, so it's easy to pipe. Let me show you what I mean. Length is okay. Instruction, let's make that x, y, and then we can just do this. And if the order of arguments is like this, you can do a fold y length like this, and everything lines up nicely. Okay, but we were working on this thing. If it's larger, then we need to do something. Otherwise, we leave the point well enough alone. In this case, where we need to do something, we leave the x coordinates untouched, but we do this thing. So let's grab that and put it in the function also. So it's this part. We do max y, maybe. I'm totally not sure about this part, but let's try it. Minus what? The y component itself. So if that is a 14 and max y is a 14, that becomes a 0. Yeah. If that is a 13, that becomes a 1. Yeah, sounds correct. I'm looking at this. Okay, so F# formatting by default, you put the then on the same line as the if. I don't know. Again, it seems asymmetrical to me. But okay, this will probably work. How many points do we have after the first fold? So this is the first fold, and then we end up with this beautiful thing with 17 dots. Let's do a quick sanity check. Do you not have a set size? Okay, let's use sequence.length. 17. I'm willing to trust the process and not even verify the grid. So let's assume this thing works. The only thing we need to do then is fold over an X. So I'm just gonna prepare stuff. Let's also write a fold X, which will be probably very similar. Trust the process. So if X is larger than length, then we're on the right hand side. Yeah, I think we can do exactly the same. But instead of tweaking the y coordinate, let's tweak the x coordinate. Max looks like some kind of commercial for, I don't know, energy drink or something. Anyway, I think we're done. If we just now use a fold to fold over our folds, we're done. I don't know why I find that hilarious. But we have instructions. Let's fold over that with a function that takes, what is it? A state, an instruction, so a paper, an instruction, and it gives us whatever. A fold of paper instruction. Oh, that is actually our own fold. So let's just do that call here, and we start with the initial paper. So if everything goes correct, this is our fully folded paper. It's at least not crashing, but how many dots do we need? We need a square. Cool. How many dots is a square? 1, 2, 3, 4, 5, 10, 16 probably. That looks good. That looks good. Okay, for the first part, we only need to fold just once. Dang it. We're going too far already. This is part 2 probably. Yeah, so let's do fold paper instructions first and count the number of points. So this is part 1. Which was 17, yes. And for our input, it is not 17. So I'm going to grab our parsing call, put that a bit down here. So everything above is definitions and function. Everything below here is actual magic. We have a point value after the first fold. Is this what we're looking for? Yes, it is. On to part 2. I might have an inkling of an idea as to what part 2 today will be asking from us. But let's verify just to be sure. Finish folding the paper according to the instructions. The manual says the code is always 8 capital letters. Oh, I love it when these puzzles like ask you to do stuff and then you get some nice ASCII art and that will be something you have to enter. I really love these puzzles. Sorry, I'm getting excited here. Yeah, so let's fold the entire thing, which we actually did. So we went way overboard for part 1. We have our folded paper here. Let's print this out. That's actually the hardest part for today. Printing out our paper again. So let's write it. Let's write a print function. Sure. I'm thinking, should we... Yeah, we cannot loop over every point. It's a sparse matrix and we want to print out empty things also. So let's figure out the dimensions here. 0 is the max is the something we do need. So this is the max x coordinate. This is the max y. I think. And instead of equal, we need to pipe it to this function. So this will give us dimensions. Yeah, it's pretty big. It's pretty big. Now we can do a comprehension or something like that. So for x in 0 up until max x, do something. For y in 0 to max y, yield something. And what will we need to yield? Oh yeah. Oh yeah. Is there not a way to do this in one thing? Instead of mapping to the x component first and then maxing, or the other way around as we're doing here? Probably not. So I'm just gonna do it this way. First we map to the relevant component and then we find the maximum of that thing. Okay, but now what do we need to do? Am I going to just return a string? Yeah, I'm going to just return a string. So this is one column. Oh no, it's column row. Let's inverse these. So it's max y. That's the row. These are the columns. And at the end of a single row, let's paste everything together into a single line. What am I doing here? I'm just trying to print out something. Why is it this hard for my brain? It's because it's doing a loop and a loop and nested loops, and when I'm writing F#, my brain has been malformed that I cannot think in loops anymore. You know what? Forget the string thing. I'm just going to print, and have all the side effects in the world. Because we are reaching the end of the part 2, and I don't care. So this is printing a new line. So here we just need to print the value in that position in our paper. So if paper dot contains this thing, then what do we DXS? Or what does the puzzle give us? This is a hit, a point is a miss. Otherwise, we have a miss. And let's print that. Is it print f? Yeah, it's print f. Let's give this a shot. Where's my paper coming from? Oh, there we go. It disappeared again. I'm losing steam here, sorry. I was getting confused. This print thing is the hardest part for me today. I don't know why. So we parse, we apply stuff, and let's now print our fully folded paper. This looks... The only thing I'm not happy about is why is it printing 2 new lines? I I only see the one. I'm confused. Oh, print. I am already putting a new line here, so I don't need to explicitly provide another new line character. Look at this beautiful square. Yeah, that works. So let's parse the input again. And let's print that. That's a lot of units. Okay, there we go. This looks like a ASCII art. Let me just grab this for me. And let's just put this somewhere. And let's start figuring out. So what do we see? P, F, J, K, Z, L, B, L. There we go. That looks correct, right? That cannot be wrong. It is correct. Cool. I love this puzzle. This was a great one. Not too hard. We finished in 40 minutes. Cool. Maybe let's do a quick 2-minute recap of what we did today. And again, I wrote 0 tests. I'm declining into madness here. Nah, we don't need tests for Advent of Code. What did we do today? Today we folded transparent sheets of paper. This is the input, so we have our points and our instructions. I see that I never used this type I declared, so let's maybe fix that. Can I use set as like a special keyword? You can do it with a lot of things, but you cannot do it with instructions apparently. With sets, sorry. Or is instruction not the correct words? Okay. Now I'm curious. Can I use a old instruction set? Can I do something like this? No. Wait, is that just said that there is a set function that takes a sequence? Oh dear. So where do I do that? Here. I can just do set? Really? I didn't know that. But it's actually the fold instructions are not the set. The paper is the set, right? Yeah. Confused. Instructions are an array. There we go. Okay, so I was getting sidetracked again, but I learned of a new function, which looks pretty cool. So I was explaining the thing we did today. Our paper is a set, and that's very easy. If you fold and you have overlapping points, they just get deduped by using a set. We parse our instruction into a discriminated union, just because I love discriminated unions. Then we do some parsing on the input, which is the function we see here. Nothing too fancy about that today, nope. And this is like the meat of the algorithm today, or folding, which was also pretty difficult for me to wrap my head around. But I think it works out. So we grab, or we are doing a map over the entire set of points, just so that we don't have to loop over that map twice, but that's just micro optimization, and you shouldn't micro optimize until you have a performance problem. But anyway, that's why you see these if else's in every fold function. If we need to do something, then we do the flipping, and otherwise we leave the point untouched. And doing the flipping is just some index subtraction. We figure out the length of the paper again, because we don't really know that in a set, and we apply the flip to a point. And then solving the part 1 was easy. We just need to fold just once and count the number of points. Solving part 2 was a bit more tricky, where we had to fold or apply every fold instruction, and that's where we use a sequence.fold to fold over all the folds. Never gets old. But that gives us a fully folded paper. And then the hardest part for me today was printing out a set of coordinates, but we managed to do that eventually. Fun puzzle. That's all I got for today. I don't really feel like raiding someone today, so I'm gonna call it a day. Thanks for watching, and I will see you tomorrow for more Advent of Code in F#. Bye bye.